Lesson 11.3, Simplifying Rational Expressions. A rational expression is an algebraic fraction whose numerator and denominator are polynomials. There are times where rational expressions have excluded values. Excluded values are the values of the variable in the denominator of a rational expression that make your denominator equal to 0. For example, if I have a over b, I would know that b cannot equal 0. That would be an excluded value, because if b were 0, then the denominator of my fraction would be 0. Here are your steps to simplify a rational expression. Step number 1, factor the numerator and the denominator if possible. Step number 2, divide out any common factors. We can also call that reduce or cancel out any common factors. Step number 3, simplify. Okay, let's first practice finding excluded values. Number 1, 5x over x squared minus 81. So, again, just to review, an excluded value would be a value for x that would make my denominator equal to 0. So to find the excluded value, we'll write an equation like this: x squared minus 81 equals 0. Let's find out what x would have to be in order for that denominator to equal 0. Well, I recognize that this is a difference of squares. So I remember that to factor a difference of squares, it would be x plus 9, x minus 9. So I know that x is positive negative 9, or better said, x cannot be positive or negative 9. In this case, those are my two excluded values. Remember, an excluded value is a value that the variable cannot equal. Okay, and in this case, x cannot equal positive 9, x cannot equal negative 9. Either one of those make my denominator equal to 0. Okay, let's move on. Number 2. 3a minus 2 over a squared plus 6a plus 8. So here again, we want to find the excluded value for a, and that means that we're going to find what makes my denominator equal to 0. So let's write the equation. A squared plus 6a plus 8 equals 0. Let's solve. We'll have to factor this trinomial. I know this is a, I know this is a, and my two numbers are positive 4 and positive 2. And so I know that a is negative 4, a is negative 2, but better said, a cannot be negative 4, a cannot be negative 2. If a were negative 4, or if a were negative 2, those are the two values that make my denominator equal to 0. Therefore, I need to exclude them. So these are my excluded values. Try number 3 on your own. Pause the video now. Please check your answers. The excluded values for this rational expression are 5 and 1. Okay, for the next few exercises, we're going to be simplifying the rational expressions, and then we're going to also be stating the excluded values. Number 4. To simplify means to reduce. Okay, so let's go ahead and reduce number 4. Okay, I guess the first thing I would do is look at the numerical coefficients, 16 and 8. I can reduce those to over 1. c squared, it's 2 c's on the numerator, 3 c's in the denominator, so when I reduce by c squared, I'm left with 1 c in the denominator. B to the fourth divided by or reducing by b, I have b cubed. Okay, so to simplify this, I'd have 2b cubed over c. That's my simplified form. And my excluded value is c cannot equal 0. Okay, let's go on to number 5. All right, for number 5, let's go ahead and first factor and simplify. N plus 3 over, and let's go ahead and factor this trinomial. Okay, I have two numbers. Their product is 21, their sum is 10. So it's positive 3 and positive 7. All right, please note that there's a common factor of n plus 3 in the numerator and in the denominator, and we can cancel out or reduce by n plus 3. Also, let's recall that there's an invisible 1 in the numerator. So simplified would be 1 over n plus 7. That would be my simplified expression. And then my excluded value, n cannot equal negative 7. Negative 7 would make my denominator equal to 0. Okay. Let's try number 6. Here we go. Let's go ahead and factor the numerator first. So we'll use P and S. Y, two numbers, their product is negative 10, so I know I have a positive and a negative. And their sum is positive 9, so my 10 is positive and my 1 is negative. And let's take the GCF out of the denominator since I can. 2 times y plus 10. Okay. Let's recall that we can reduce, and we do have a common factor of y plus 10 in the numerator and in the denominator, so we can cancel that out. Okay, in simplified form, this expression is y minus 1 over 2. Now, because there is no variable in my denominator, there are no excluded values. Okay? Try number 7 on your own. Pause the video now. Okay, my simplified expression is 12 over x minus 4, and my excluded value is positive 4. Okay, let's do number 8. We'll do this one together. Let's factor. I have x, and negative 35, negative 2, so I know I have negative 7, positive 5. This should be second nature to you by now in terms of factoring. So I have positive 14 and negative 9, so I know it's negative 7, negative 2. Okay, so let's go ahead and reduce by the factor that they have in common. And so simplified form is sorry about that. It's x plus 5 over x minus 2, and my excluded value, x cannot equal positive 2, because we know that that would make our denominator equal to 0. Remember that your excluded value is the value that makes your denominator equal to 0. Okay? 0 can never be in the denominator of a rational expression or a rational number. Okay. To find the zeros of a rational function, what you will do is make f of x equal to 0, and then you will solve for x. So, if f of x, for example, is equal to a over b, and we substitute 0 for x, f of x equals a over b, we're going to be solving for making this rational expression equal to 0? Well, what you need to know is that in this case, we're only going to be concerned about the numerator, making the numerator equal to 0. Because if the numerator is equal to 0, then 0 divided by anything at all equals 0. Okay, and remember that excluded values is when the denominator is equal to 0. So again, to find the zeros of a rational function, your numerator is equal to 0. To find the excluded values of a function, your denominator is equal to 0. All right, let's work on this one. So f of x is equal to x squared plus 2x minus 15. Let's start by trying to simplify. Let's do that. So x and x, we've got two numbers. One is positive, one is negative. I've got negative 3, positive 5, okay, over x plus 1. Okay, so to find the zeros, all right, to find the zeros, all I have to do is concern myself with making the numerator equal to 0. Okay? So let's set up my equation. X minus 3 times x plus 5 is equal to 0. So x is positive 3 and x is negative 5. Those are the zeros, or the solutions to this function. Now, we need to find the excluded values as well. So, to find excluded values, then we're concerned, as you know, with the denominator being equal to 0. So let's set that up. X plus 1 equals 0. So x cannot equal negative 1. That's my excluded value. Always check to see if one of your zeros is an excluded value or not. And in this case, it's not. Okay? All right, number 10. Solve that one on your own. Pause the video now. Okay. Sorry that the work is so scrunched up for this one, but I really didn't have enough room on the screen. But the simplified form of the original function is n plus 5. Here it is, n plus 5 over n plus 1. Okay, so for my zeros, I make the numerator equal to 0, so n equals negative 5. And for my excluded values, I make the denominator equal to 0, so n cannot equal negative 1. Okay. Take some time to do some extra practice. Okay, state the excluded value for each rational expression. So all I want you to do here is state the excluded values. You're going to do number 4, number 8, number 14. Remember that for excluded values, the denominator cannot equal 0. Okay? And then on these, you will be simplifying and then stating the excluded values. Simplify and then state the excluded values. So on these, work on number 3, number 9, and number 12. Okay, write down any questions that you have. Make sure that you practice simplifying rational expressions, stating excluded values for tomorrow. We'll go over this tomorrow. God bless you. Have a great night.